Today we're going to start with the LaTeX course. First of all, can you hear me correctly?
Yes.
Yes. Is it too loud or is it fine? I think it's overmodulating a little bit, but okay. So, getting started with LaTeX. And I say LaTeX for a reason. That's because it's not LaTeX. There's a slight difference in pronunciation. There's also a slight difference in meaning. So we're not going to be talking about LaTeX, but LaTeX today. First of all, a bit of who am I? Well, I'm a third year EE student. So exactly 2 years ago, I sat where you are all sitting. Only I think it was Spiegel 6 and not Spiegel 1. So yeah. And then I also received this course by Matthijs from Minnen. He was from Scintilla's masterclass as well, and he gave this course. And well, I thought it was very useful, so I actually used it a lot. And that's also the reason I'm giving this course today. So yes, I'm active at Scintilla for the masterclass committee as well. And one other thing, I'm not a super duper expert in LaTeX, but I do use it for practically all my reports. So I've used it for the last 2 years pretty extensively. And I hope I can give you an introduction at least on this. So the goal of this course. The goal of this course is to learn an alternative way of writing documents that might be beneficial to the rest of your, well, actually your entire academic embraces career. So we're going to be seeing why it's beneficial to use this way of writing in a moment. But I want to say, okay, so it's actually a way that can really benefit, especially later on when you go to your bachelor thesis, when you go to your master thesis perhaps, even when you're doing your doctorate research, postdoc research, but also writing reports for companies that you might work for and stuff like that. So, yeah. I want to start with a question, and that is the project organization and report. What do you expect to find in this report? So I want you all to think about this for like 20 seconds, and I will ask a few of you to answer. And I'm looking for things like, what will you find in your document? So not the chapters on themselves, but what are the kind of elements that will be in your report? Okay, so can somebody in the second last row give an answer? You over there with the red shirt with the stripes on.
Images, tables, things like that.
Images, tables. Okay, and somebody here in the front, can we supplement that?
Formulae.
Formulas, yeah, formulae. References. Maybe somebody online has another... okay, that's a shit. Well, yes, those are some very good examples. Those are elements that you find in your report. But also maybe headings, chapter sections, the header and footer of pages, footnotes. Those are all things that you can find in your report. And those are also maybe things that you struggle with in other document writing applications, especially when your file gets large. What's in the name? LaTeX. Well, it comes from tech, which is Greek for techne. That's skill or art or technique. And it was actually designed by Donald E. Knuth in 1987. Well, he was a scientist, and it was designed for technology and typesetting, and it was kind of made it for mathematics papers. Because at that time, there weren't really any good tools to write mathematics papers that have lots of formulas in them. And that's where LaTeX was born from. So actually a lot has changed by then, but also not really. The current version of TeX is 3.141592653. You might recognize this number. It's pi with a certain accuracy. The reason for this is because they haven't really changed the way LaTeX works in a long time. It's practically still looks the same as version 3.0, but they did do bug fixes and they're still doing bug fixes. It's still an active project. So that's why they use this version numbering, and in 2021 there's still bug fixes. But the reason for this also means that you can practically take a LaTeX document written in 1987 and put it in a LaTeX interpreter today, and it will give you your document. So it's very version friendly, and it's actually also, when I was talking with Luc of giving this course, he said, yeah, actually 2 days ago I was combining 2 old documents, and it really gave a big mess. So I ended up doing was creating one LaTeX document with both things. Well, in LaTeX you wouldn't have that problem. You could just take the 2 old documents and throw them in there. It would work. There's a saying that really describes LaTeX in a good way, and that is, it makes difficult things easy, and easy things sometimes very difficult. I want to say this beforehand because I will show you some examples later on, and I will show you some ways, and you might see, oh, this looks very complicated and way more complicated than it needs to be in order to write my document. But as this curve shows, you might be in this area over here where you think, oh, I can just do it in Word because Word is easy. Eventually, you will really start appreciating LaTeX once you get the hang of it, and once you actually make large documents with multiple people, with multiple different settings, multiple different chapters, you will have a real benefit from using LaTeX. So also for this course, it's not mandatory to write your report in LaTeX. However, it's strongly recommended, and also it might be mandatory in some other future project that you will get. So I really suggest that you stick to LaTeX in this project so that you can already get learning experience from that and also feedback. And you already have some experience when you need to use it later on. But what actually is LaTeX? Well, LaTeX is a language that allows you to create documents in almost any text editor, focusing primarily on content and structure and not how it looks. So here's 2 examples. You see here a default Word page, and you see how a LaTeX document might look when you are writing it. So you can see it kind of looks like a programming language, and that's because it is. It's more similar, however, to HTML. So in LaTeX you write your report in a very structured manner by using all these commands, but it allows you to focus really on the content and the structure and not the way it looks. You separate the way it looks by having certain templates and directives that tell how the structure looks. So that's also similar to maybe how HTML and CSS work. However, a fun thing, LaTeX is actually, a programming language is actually Turing complete as well. So that's a fun thing. Well, there's a difference between content and looks, and that difference in Word is not very clear. You have basically your all the properties and your text coloring and all that kind of stuff that you can select. In LaTeX, you really specify the content and the structure. So you do not say this text should be italic. No, you say this is an emphasized piece of text. And then maybe in the preamble of your document, you specify, okay, all the emphasized text in my document must look a certain way. For instance, it's blue and it's actually italic. Or it's red and it is bold. You know, you can specify that, and that's also where one of the main powers of LaTeX comes. I can now take my own entire document, move it to a different template where those rules are also different. So, for instance, a rule is instead of blue and italic, it should be red and bold. Well, my text would just give a new document that looks consistently in another way, and where all the emphasized text is also another way. So, an example, what's the difference between these two lines? They both say new chapter and they both look the same. But in LaTeX there are actually two different things, and here you're doing something that is kind of discouraged in LaTeX. It's the same as using the I tag in HTML, that's deprecated. Here you're actually saying, okay, I want to force that this is bold-faced and I want to force that this piece is large. But the better way, or to do that, the correct way, is to say, okay, this is a section, new chapter, and then maybe in the beginning of the document I have specified that this is bold-faced and large. A chapter can also do something else, and we will see that later on. There's a real big bunch of useful tools built into LaTeX, but also it's completely expandable. So you have thousands and thousands of packages that you can use to make this whole document that you sort of program function in the way that you want. So let's put it against some other document editors. In Word we have a really nice equation editor. It's actually, I think, one of the best equation editors out there. But in LaTeX you have an entire language that can specify mathematical equations. Once you get the hang of this language, it's super quick to type. In Word you have to click on all the things. Yeah, sure, you have a few shortcuts that you can make. Once your equations start getting very large, or you start getting very many, you will see that in Word this will take up more and more time. And maybe you're working in Google Drive, then you have also an even bigger problem, because many of the functions are not supported. For instance, if you want a real good editor to create matrix equations that you will get in the future or already have, I don't know, then it will start getting one big mess, and in Google Drive it's practically impossible, so you have to use another tool, create an image, move that into your document. Well, in LaTeX I can just write it down in a certain way. If this scares you in the beginning because you don't know all of these commands that describe equations, there's also tools on the internet where you can still use the sort of Word way of making an equation and then export it to one of these. Next lecture I will also show you a tool that I use a lot that just allows you to capture a part of your screen and then outputs using optical image AI. It will output your LaTeX equation for you. So there's a lot of cool stuff you can do with that. So some advantages of Office over LaTeX, there are a few, and that is showing what you get immediately. You are editing a WYSIWYG, what you see is what you get. In LaTeX, that's not so much. There's actually a clear separation of content and formatting, and you saw it when I showed the picture, that you have a text with a lot of code, and you have your actual document, how it looks. But that is also an advantage. As I told, you can just switch the templates. Mathematical equations are easier, I just showed, once you get the hang of it, are easier in LaTeX. Some advantages of Office are also, checking of spelling and grammar. In LaTeX default, that's not done for you. But in the editor I'm going to show you that I use, Overleaf, that's actually also done for you, so that's not really a disadvantage. Office can be easier to use, and then I say, especially for small documents, and especially if you don't know LaTeX all that well yet. And Word has everything in one package. LaTeX uses a ton of packages. But that's also, again, you can also see it as an advantage because you can make your own packages. You can use other people's work a lot easier. LaTeX has also another real cool feature, and that has to do with formatting. Formatting, for instance, of images and also doing references. Because of this clearly structured way and rules you apply to this structure, you can have something like an image that you always, for instance, put on the right or have text wrap around in a certain way, and you really can really make hard rules how your document looks in this way. That means no more moving your image where the entire document breaks, where everything falls over, or maybe even when you export your Google Drive document to Word, everything just goes to, well, shit, basically. That's not a thing in LaTeX. There are hard rules. If you mess something up, that's just like programming, you can fix it yourself. There's also a lot of functionality built in for automation and also for typography. So, a poll. Up to now, at this point in your study, who here uses LaTeX? Please raise your hand. Okay, maybe I should have started with that. Okay, and who uses Word? Okay, and Google Docs? A few, okay. And Notepad? Yeah, I can still see one hand. You use Notepad to write your report? Okay. Well, there's many of you that use LaTeX already. That I think is a very good sign. So how would you describe your proficiency with LaTeX? If one of you can answer? Yeah?
How do you solve bottomless errors in the first place?
Hmm?
How do you solve bottomless errors?
How you solve the parse errors?
No, sometimes there's like a blue warning or a flag that says bottomless error something something. How do you solve those?
Okay. I think because many of you are with LaTeX, I will prepare something about that for the next course. Last year when we did this course and the year before, there were like 2 people in the room that used LaTeX. So that's kind of where I made the course and especially this introduction lecture for. There are a few tricks to solving errors. Yep. Especially the blue errors are usually to do with that you yeah, with spacing. So you actually have these hard formatting rules that I talked about, and you are doing something where 2 rules kind of mismatch. So you're, for instance, saying, I want this box to be very large, but I also want to force this image on this place, and then there can be some sort of styling error, so then you get those blue boxes. I think most of you who put their hands up in LaTeX, do you use overleaf? Yeah. Okay, well, for the rest that don't use LaTeX yet, and also there's a lot of people online, so I don't know your answer. There are editors that you can install on your computer. Most of them are completely free, such as TechWorks. And an editor, it's like an IDE, basically. It's not the actual language itself. And then there's also a sort of compiler that is, for instance, PDF LaTeX or Excel LaTeX or Lua LaTeX, I think. So basically you have an editor, there you just write your text. Then the language itself is the Tech language. And then you have a compiler that puts the file .tex, the Tech file, and makes a document format. Now LaTeX can be exported to multiple documents. Usually we only see it in PDF. That's because PDF is practically showable on all devices and you can print it. So yeah, most of the times your report is going to be in PDF. It also supports a lot of things like clickable links, videos, photos and stuff. So that's the things that you have. There is a very nice program that's called Overleaf. It's actually a website, and it's kind of combines the Google Docs features with these programs that you can install on your computer. So for the university students, they actually have access to Overleaf Premium. Even if you don't have access to that because maybe you stopped being a student here, you can practically do everything in Overleaf for free. And you have an editor and a compiler. I will show it in a moment. But you can also collaborate with other people. So everybody can work in the same document and you can chat. It just works real time. There's one thing that doesn't work real time very much, and that's Control-Z. Just roll back, because it rolls back the action of your other other collaborators. But in any other respect, it's very actually very effective of working together on a document. Also, because LaTeX allows you to split chapters and sections in many different files. So you can even work and not have everything be jumping around because the other person is working in the section above you. You can just use different files and work in different files. But in Overleaf it also works quite well, working in the same file and having multiple collaborators in the same file. Because LaTeX works with these files, it's also possible, if you want to collaborate, for instance, to use Git or a versioning system. I think even in Overleaf you can use Git to make sure that you can save commits of your document and roll back these commits if you screw up something very terribly. So that's the editor. I will now show you the editor, and I will not show you TechWorks, but I will show you Overleaf. And I will show you a few examples of the reports that I made with LaTeX. So one of them is the current report I'm working on for my minor. And it's the ontwikkelingsdossier, they call it, where you have to describe what you do on the school that I work at. So you can see that you have headings, you can have nicely formatted images even with certain packages. You can actually do a lot of formatting, and you can see this is the Overleaf editor. You can see that when I go to the editor, the content here is just text that I can focus my attention on, but it's in a sort of box. And I defined the rules for that box, that it needs to be yellow and have that nice shadow and stuff. I defined that somewhere else. And everywhere where I use this quote blocks, my text will appear in this way. So that's an example. You can see here in Overleaf that I have my editor window over here. And then I have a preview of how the actual PDF looks over there. And every time that I want to preview what I did, then I need to press this recompile button, and it will create the document. And I can just download it here and upload it to Canvas when I'm done. Like I said, I'm not a super expert, but also I used to write, for instance, this document with other people. So yes, there are some warnings, but as long as there are warnings and the formatting is the way that you like, then you can still use it. So this is an example of a 2-column layout for the SI lab that you will also be having in, I think, the next year. You can see there's a lot of equations in between the text, and it's very just... Here you can see one of those equations. When you get the hang of it, it's actually quite easy to just jot that down. And also you can then reference to it in your text. So for instance, here I use the package cleverref, and I can just say, okay, I want to reference to a certain section or to an equation, and I will have the formatting that belongs to that certain reference in here. So for instance, equation 3 well, it will always, a reference to equation will always look the part, and I can also have it instantly jump to that equation or to that section header. So I can use hyperref, that's a package, to make my links clickable and to make the whole document a lot easier to navigate. Here's another example, the Segway project that you will be having also in your, that's module 6. So here you can see there's also 2-column layout with images, but also a lot of matrix equations that you can do quite easily in LaTeX. Also something cool, you have packages to just highlight code. So for instance, your MATLAB scripts you can put in there. And here is the presentation that I'm giving, also possible to create in LaTeX. So, the way that LaTeX works is usually you see all of these instructions, those are commands, and they are tied with a backslash, so not like in Minecraft commands with your normal slash, but you use a backslash in LaTeX. And usually you give a certain command name, and you have parameters and a body in that command. So there's also now this is an example command, for instance. So the document class, one of the first commands that you will see in your document, and this displays basically the main formatting rules or the fallback rules of that document. So I can have, for instance, an IEE trans. That's a certain report that follows rules that are specified by the IEEE organization. So it actually has a lot of rules that we as electrical engineers kind of stick to when we are writing scientific articles. I can just import that with my document class and have the main body already follow a lot of the rules of IEEE. I can also have a book or report or beamer, an article. There's a lot of classes in here. And for instance, I can give some options. Okay, it's written on A4 paper. That's the sizing. I want a 2-column layout, a landscape. Now, as I said, these are fallback rules, so you can also use packages and a lot of stuff yourself to make it different. But this is something you can start, where your document can start on. Other examples use package, we'll import a package. TextBF is an example of a restricting styling rule in your document. If you are a LaTeX purist, you will probably not use that, but you can use it to just make some text bold. And these commands all work kind of like the span does in HTML. You also have something else, and that are environments. They're more like the diffs in HTML, where you basically create a certain environment where certain formatting rules, for instance, might apply. Well, and then an example is this box where you see this text in. It's also an environment that creates a gray box, but a figure might also be in an environment, or a table might also be an environment. The structure of your report, it will look something like this. You can use the chapter, the paragraph, the subsections, the subsections to create a structure in your report, and this will also automatically, for instance, be picked up by the table of contents, or it will be picked up by references where you reference to a different chapter, and you can immediately go to that chapter. So there's a lot of stuff that you can program into your document that is attached to these chapters, but it's also just the main structure of your report. I will show you a very basic example. This is kind of the least amount of LaTeX, a sort of hello world example. You'll see that you start with this document class. There is also the package graphics that's imported to show some graphics. And then there's the beginning of your actual document where you format your structure. Well, this is a, a very simple structure. It's just one section, welcome, with some text. And there's the nice LaTeX command that creates the LaTeX logo with the weird spacing you see on top of the slide as well. So I wanted to give you all this as an instruction or as an introduction to LaTeX. So some pointers if you need help. The LaTeX wiki book, it's very comprehensive. There's a lot of stuff in there. The tech exchange, if you want to fix errors, most of them probably already done by somebody, similar to programming language where you basically look all your problems online on the stack exchanges. There's also a tech exchange. There's on Canvas, there's a manual with the basics of LaTeX. I will update this manual with some contents, but already it's very complete, so you can look at that one. It's basically a place where a lot of the basic information of LaTeX is already talked about, and it also gives some tips of where to look for more advanced information. And remember, Google's your friend, of course, and also feel free to send me an email if you have a particular question or something you want to do in LaTeX but don't know how. So next time, well, I was going to go over the chapters, sections, figures, tables, and more in the next section, because then you will have to actually write part of your report, so it's useful to know. After that, you will learn how to look for references, so you will also in this course learn different ways of working with references, and also an automatic way I will teach you that's very cool when you use LaTeX. So that's how the rest of this course will look. If there are a lot of you that are quite versed in LaTeX, and I don't know how many of the online people are quite versed in LaTeX, maybe we can do some poll on that. Then I will also include some more advanced LaTeX techniques in the course. Otherwise, I'm just going to stick to the basic stuff, so to get you started on LaTeX. Last but not least, I want to ask, who here now thinks they will use LaTeX for their report? Okay, so that's a very clear majority. I think only 2 hands are missing. That's awesome. If you want, you can try to create an Overleaf account now. I think we still have, there's still like 12 minutes left before your break. And otherwise, I'm going to open it up for questions right now. And the rest of you who don't want to do either of those things can just leave and have the break.